Hello, welcome to the video notes for lesson 6-1. This lesson is about adding and subtracting polynomials. Begins on page 1 from your notes packet from your new unit, which is polynomials and factoring. There will be a lot of new vocabulary in this topic, so it's really important for you to pay attention and ask questions if there's anything that you don't understand. We'll be doing some review and some vocabulary activities together in class also to help you understand it. But again, if you don't understand something, it's very important to ask questions. Okay, so first let's take a look at the learning target. I can perform arithmetic operations with monomials and polynomials. Okay, so we first need to understand what monomials and polynomials are. The arithmetic operations are addition and subtraction that we're going to start with, but then we'll see others later on in other lessons. So let's talk about a monomial. Monomial, it's actually not really named too well. It would normally be, or you would normally expect it to be, mononomial, and those words are Latin, meaning basically one name or one expression. So a monomial is an expression that is a number, a variable, or a product of a number in one or more variables. Basically, it is one term, a single term. So if you look, -4 is a monomial, m is a monomial, 3xy to the third power is a monomial, y over 6 is a monomial. Now, you might be saying, well, this one here has more than one thing in it. Yes, but the key is, and you'll probably understand a monomial better when we talk about a polynomial, is that it's okay if they're pushed together because they're being multiplied. But the minute you add or subtract, then you're creating more terms, and it's no longer a monomial. So let's move on down. Polynomial is a monomial, or the sum or difference of two or more monomials. So it's kind of weird. This uses, again, this is Latin, so poly means many and nomial means name or number. So typically the definition goes the other way. A monomial is a polynomial that only has one term. This definition is saying, well, it's actually a monomial that can be added to another monomial to make more than one. So there's some specific types of polynomials. There's a binomial, which has two terms, and then a trinomial, which has three terms, and then there's obviously others that can have many terms, like this one in the middle down here has 5 terms. For that, we're just going to call it a polynomial. Don't worry about, there is a more specific name for it, but I don't know it at the time, and you don't need to know it, other than an appropriate name for it is polynomial. But it's when you have addition or subtraction in between these terms, then it's more than one or many. So these are binomials, they're a type of polynomial. These are trinomials, so 1, 2, 3, 1, 2, 3. Notice what I'm leaving not underlined is the addition or subtraction sign in between. So that's like the separator, if you will, and separates the terms. So, okay. Standard form means that the degree of its monomial, now this I know you all will need to understand as well what the degrees are, terms decrease from left to right. So these first three expressions are written correctly. The last one is not. And we're going to rewrite it correctly, but you'll need to understand what a degree means in a second. But it has to do with the exponent. So this is a higher degree term, this is the next highest, and this is the lowest. Same with this one. This is a higher degree term, and it has to do with that exponent, and then the next one, and the next one, on down. So, now there's no exponent for 1. And if we were to think of it, well, technically there is, it's 1. But it's a 0 degree term, because it has to do with the exponent that goes with the variable. Now, the variable for x, or for this term is x, it's you don't see the exponent, but it's 1. So this is a first degree, second degree, third degree, and fourth degree. So let's write down the definition for standard form, or excuse me, we already know the definition, for degrees. The degree of a term is determined by the exponent of the variable or the sum of the exponents of the variables. Of the variable or the sum of the exponents of the variables. This last part has to do with if there's more than one variable and what you do with their exponents to figure out the degrees. Alright, so let's go back up here to the example that was not written correctly. 8 minus 3x minus 10x squared. That is not correct. It needs to be written this way. So the term with the highest degree is the negative 10x squared. Now, I know you might be saying, well, that was a minus sign. Treat it like a negative, and then add everything else. Well, the next term is that has a variable is the negative 3x or the minus 3x. So we're going to treat it like adding a negative or subtraction. Then the last term then will be 8 plus 8. Alright. So we have some examples that we're going to do on the next page of adding and subtracting. We'll be writing our answers in standard form. Luckily they'll just work out that way, so it won't be a big deal. So go ahead and look at page 2. So we are going to be adding polynomials. There's two methods we're going to be using. Method 1 will be adding vertical, going up and down. Method 2 will be adding going horizontal. Alright, so for adding, it's actually usually pretty simple. Just make sure you watch out for the signs. Treat minus signs like negatives. So 2x to the third plus x to the third, remember this is like 1x to the third, is 3x to the third. Negative 4x squared plus negative 3x squared is negative 7x squared, and then 3 plus 1 is 4. And there's your answer. Now, if you're going to add horizontally, this goes back to something you are already familiar with, combining like terms. So, I'm going to combine this term with the other term that's like it, and when I do this, I try to include the sign that's in front of it. So 2x cubed plus x cubed is 3x cubed. Now I'm going to use a different symbol for the next term. I'll put a square around this, or a box around it. Find the other one with an exponent of 2 and the same variable. So negative 4x squared minus 3x squared is negative 7x squared. And then maybe for the last one I'll circle it. So 3 plus 1 is 4. I think this method's a little sloppier, but when you get really good at this, adding horizontally, because a lot of times this is how they are written, is a pretty easy thing to do. Okay, subtraction is a little trickier. This is what you're going to need to do. Distribute the negative sign. Treat it like you're distributing a negative 1. Okay, so again, two methods, vertical and horizontal. So when we do the vertical, I'm going to distribute the negative sign. Basically, I'm going to make the sign of everything the opposite of what it is. So this becomes negative 6y to the third power minus 3y squared plus 3. Now, I know it's subtraction, but really I'm going to be adding these going vertical. So 8y to the third power plus negative 6y to the third power is the same as 8y to the third power minus 6y to the third power, which is 2y to the third power. Negative y squared plus or minus 3y squared is negative 4y squared. And then 7 plus 3 is plus 10. Okay. Same thing over here. Now there's nothing to distribute for the first part of this expression. So even though there's parentheses around it, you don't need it. So it's really just 8y to the third power minus y squared plus 7. I'll distribute this negative sign, minus 6y cubed to the third minus 3y squared plus 3. Be careful. The biggest mistake students make is that they don't distribute the negative sign to everything. If you leave something out, that'll obviously give you an incorrect answer. So, combine your like terms, include the sign so you know what to do. 8y cubed minus 6y cubed is 2y cubed. Negative y squared minus 3y squared is negative 4y squared. And then the last one, positive 7 plus 3 is plus 10. Alright, so that's it. Hopefully you're not too confused with this. Don't worry, we are going to be spending a little more time talking about it in class. Unless, of course, all of you understand it very well, and maybe I'll have to quiz you on the way in just to see. Part of me knowing if you understand it will depend on how you do with this page. So you are expected to try this on your own. I understand if you can't get it, but I want you to at least try it on your own. So the directions: simplify the expressions. The list of correct answers is listed at the bottom. Cross out the answers as you solve the equations to reveal the answer to the riddle. What did the mathematician work at home? Or excuse me, why did the mathematician work at home? And then the answer, he could only, and then you've got to come up with it. So there's a whole bunch of expressions here that you'll simplify and cross out. Good luck. If you didn't understand something, go back and watch the video again or come and see me. Good luck, and we'll see you in math.